This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Did you know that thunderstorms can produce gamma rays? Yes, indeed, and NASA is studying them using a modified U-2 spy plane called ER-2. An international group of researchers recently captured the most detailed data on gamma rays and thunderclouds ever by flying into the storms. Thunderstorms create powerful updrafts and downdrafts of wind that accelerate air and water to high speeds. As ice crystals collide with these swirling air currents, electrons are stripped away from them, generating the electric fields that produce lightning. These free electrons can create flashes of gamma rays, which are the shortest and most energetic waves in the electromagnetic spectrum. Thunderstorms can emit two different types of gamma ray radiation. The short gamma ray flashes can last for a few minutes, and the longer gamma ray glows can last for up to hours. The ER-2, or Earth Resources 2 aircraft, flew as close as safely possible to thunderclouds that stretched as high as 10 miles. Doing so allowed them to gather the most detailed airborne analysis of gamma rays and thunderclouds ever recorded. Here's the team to tell you more about the project. Francesca Becker, the ER-2 project manager, Alistair Ma, the crew chief, Timothy Lang, the lead research aerospace technologist, Wasson Miles, the aircrew life support technician, and Daniel Shai, the research physicist.
Airborne science, we study all kinds of different weather. Lightning is obviously a very big part.
First name Alistair, last name Ma. Engineering technician / crew chief. It's very exciting to be working with the ER-2. My role is to design a flight campaign that can put us over thunderstorms as much as possible. We are hunting for gamma rays from thunderstorms known as terrestrial gamma ray flashes.
So doing this research helps us learn more about how lightning forms and reacts with Mother Nature.
We are hunting for gamma rays from thunderstorms. These gamma rays can come in two forms. One are low energy, long-lived things called glows, sort of enhancements in the background radiation. And then within those glows, you have things known as terrestrial gamma ray flashes, or TGFs, and they're very powerful emissions of radiation from thunderstorms.
In order to go and observe these TGFs, we are using the ER-2 aircraft, which is a high-altitude, high-endurance aircraft. So it gives us the ability to fly a distance away and stay over those targets of opportunity for a good amount of time so that we can make those observations.
One of the first things we're going to do when we come into work is let the instrument teams get about an hour. They're going to go through their instruments, make sure everything's working correctly, do their pre-flights, along with us doing our pre-flight.
So IStorm is an instrument to detect gamma rays from these energetic events from thunderstorms. What we hope to find is to understand the energy of these photons, and that gives us insight into the energetic processes that happen in these gamma ray flashes.
First of all, we pre-flight their suits and make sure everything's good, all the leak rates are within tolerance, and then when the pilots come down, we'll suit them up. And then he has to pre-breathe 100% oxygen. We got to get as much as the nitrogen out of his system as possible. That's why he's pre-breathing 100% oxygen for an hour. They can develop the bends if they go up too fast. Bubbles will form in your veins.
We're going to tow the aircraft outside. We obviously need fuel, which we bring our own fuel tanks for. We'll fuel it, and then after we've fueled it, we'll take it over to the launch spot. After that, we're going to get the aircraft ready to go, get the pilot inside. In addition, we're collecting validation data for NASA Lightning satellites, the Lightning imaging sensor on the space station, as well as the geostationary lightning mapper up on geostationary orbit.
With the success of being able to observe TGFs on this mission, it'll be world known, and the research will help people globally.
The flights were done at MacDill Air Force Base in Tampa, Florida, and conducted over 60 hours of observations. Researchers from the University of Bergen in Norway, the U.S. Naval Research Laboratory, and 3 different NASA centers participated in the study known as Airborne Lightning Observatory for Fly's Eye GLM Simulator and Terrestrial Gamma Ray Flashes, or ALOFT for short. The data that the program gathered could help scientists see where storms are strengthening and provide extra lead time of information to keep public safe from the threat of lightning. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.